Unless you really want it, then I could find something.
No, I'm good.
Alright. Hi, good. I'm Mr. Crossell. Nice to meet you.
Hi, Mr. Crosswell. I'm good.
I know.
So, if you guys don't want that to happen, you just use the proper thing.
So on this Liddy Fun Sock Friday on the 11 out of 10 of October, okay? SWBA students will be able to solve compound inequalities. 3.4 compound means we're putting things together, okay? We're compounding. We're putting multiple things together. So for a compound inequality, we're combining two inequalities. We'll talk about how we go about this and different things of that, okay? So compound inequalities, two inequalities that are connected by and or. These are connected by the word and or. Or. Okay.
Okay, hold on.
Two words. Okay, Dylan.
What? Oh, yes.
Yes, me too.
Yes. Hold up your desk.
My desk?
Yes.
Probably not. My shoulder's a little sore. Oh, yes. I agree. Okay? So if the compound inequality contains and, then the graph will be the intersection.
That's like on a road.
It could be on a road, right? That's a good way to think about it. The intersection of the two graphs. So an intersection for us is going to say where the graphs share, where both are true, okay? The intersection of a road, that's where two different roads are at the same time, right? You have a road running this way, a road running this way, and where they intersect is where they meet, okay? It's the same thing for these graphs. So two graphs, and the intersection will be where they both are, where they meet. That's going to be our answer for these, okay? Now, it can be written in two ways. We can write our ands in two ways. We can say that x is greater than 3 and x is less than 5. You can write it like that way. X is greater than 3 and x is less than 5.
Yeah.
So notice how we have two different inequalities here, and we're combining them with the word and. So we're saying they're both going to be true. It's not just one or the other. We're saying both are true. Not only is x greater than 3, it also has to be less than 5. Now we can also write it like this. We can say 3 is less than x. We can say that, right? If x is greater than 3, we can say that 3 is less than x. We know we can flip that around, okay? And then what we can do is we can say, well, x is less than 5, so we can combine it like this. And saying, hey, 3 is less than x, and x is less than 5. So this means x is somewhere between what two numbers? 3 and 5. X is somewhere between 3 and 5. It could be 3.1, it could be 4, it could be 4.1, 4.3, 4.5, 4.9, okay, 4.999, okay? But it can't be 5, it can't be 3. That's the same thing it's saying here. It has to be greater than 3, but also less than 5. In set notation, our set notation, the braces we're using, okay? We put it in this format. We say x such that, and then we write it like this. The smaller number is less than x, which is less than the larger number. So it would be written like this. So an example right here would be if we put this in set notation, you have your brace, x such that 3 is less than x, which is less than 5. And a way to remember which one goes where, you might say, oh, which one goes where? Confused. You put your smaller number first, then your bigger number at the end.
Wait, so what did they answer before?
Okay. Well, it could be 3.1, couldn't it?
You're right.
Okay. So that's why you can't just say 4, because 4 is one of the answers, but there's infinitely many numbers between 3 and 5. There's infinitely many. There's 4, 4.01, 4.001. You know, you can just keep going forever. That's a great question. Then we have these OR graphs. Okay? Or, then the graph will be what we call the union. Call it the union of the two graphs. Union means it's being brought together, okay? Or a combination of some sorts, okay? So the union, in math, we're going to say it's a solution of either inequality, but not necessarily both. Okay? It's a solution of either inequality, but not necessarily both. And we'll talk about examples of these. Right now we can say is x is less than 3, it's smaller than 3, so like -2, 0, okay? Or x is greater than 5. So notice we use the same numbers as up above on the and, but our signs got switched. Okay? So let's say we're saying x is less than 3, so it could be like 0 or any negatives, or it's greater than 5, so it's like 10 or 12 or something like that, okay? So it's on one of those two sides, but not in the middle. This is saying x couldn't be like 4 in this case, because 4 is not less than 3 and is not greater than 5. It doesn't fit into either of the categories. So let's walk through a couple of examples here, and I think that's going to help it come alive to us as we normally do, okay? So, solve the inequality, graph the solution, write our final answer in set notation. We're pretty used to those instructions by now, I'd say, given that this is our third lesson using those instructions. So we have our first one, x is less than negative 5, or x is greater than 1. X is less than negative 5, or x is greater than 1. Do we have to solve anything here? Are we adding and subtracting anything here? No. The variables are already by themselves, and they're already on the left side, which we like. So it's already solved. Now we need to graph it. So I'm going to draw a graph. Now here, what numbers do I see here? 1 and negative 5. Now before, we just had the 1 number, right? And so we just put that in the middle, didn't we? Here's where we're getting a little bit different. We're going to put both of these numbers on here, and you really only need these two numbers. So which of these two numbers is going to be further left? Negative 5. Which one's going to be further right? 1. Okay? So we're just going to put those two numbers on here. Whenever you're given two numbers in a compound inequality, we're just going to put those two numbers on there. Because now can we already tell which way is going negative and which way is going positive comparatively? Yeah, we can. So we don't need to put the three numbers in this case. So what kind of circle, if we just look at this one, if we graph them just separately, what kind of circle would we put for negative 5? Open, right? It's not or equal to. And which way are we going to shade it? We'll draw our arrow. To the left. Because those are numbers less than negative 5, that's the way this arrow goes, and the variable's on the left. Okay? So it's going away from 1 in this case. Or x is greater than 1. So what kind of circle is going on 1? Open again, because it's not or equal to. And which way are we going to draw our arrow?
To the right.
To the right. So notice, do these arrows go in the same direction at all? No. So our solutions are anything left of negative 5, anything to the right of 1. In between here, is that part of our solution? No. Hannah's shaking her head, no, I agree with her, okay? This is not part of our solution. So negative 5 to 1, not part of our solution. Less than negative 5, yep. Greater than 1, yes. So now we put it in set notation. We're going to put x such that, and we just write these two inequalities. We just write the two inequalities. And I like to write them from lower number to greater number. So I'm just going to write this inequality. X is less than negative 5. I'm going to put that word or in. And I'm going to put the bigger one. X is greater than 1. We put it in our braces. And that's our set notation. So in this case, because we have two inequalities with the word or, we're going to write both inequalities with the word or between them as our answer in our set notation.
I feel like this stuff we had to work on.
Oh, just you wait.
Oh no.
In classic math fashion, we're going to get a little more complex as we go through it.
How dare you?
Classic math action also didn't have
Or you could just make it really easy for everyone.
Hopefully we'll learn it so well that'll be easy, okay? We're going to look at number 2 here. We're going to look at number 2 here. And what do we notice about number 2? It's a what kind of problem? It's not or, but it's and. Okay, so our graph problem will look a little different. So once again, is this already solved for us? Yeah, okay. So if we were to graph these, we said when we have two numbers, we're just going to put both of the numbers there. Which of these numbers would go on the left, 3 or negative 3? Negative 3, very good, Serenity. And which one would go on the right then? Positive 3, right? Okay. So if we look at graphing each of these, we can graph whichever one we want first. I'll just start left to right. X is less than 3. So what kind of circle is going to be at positive 3? An open circle, because it's not or equal to. And which way am I going to draw my arrow?
To the left.
To the left. And I'm not going to actually put the arrow on it right yet, and we'll see why. Okay, I'm not going to put the arrow on it yet, and we'll see why. Okay, that's a little different. Now if I go to graph the other one, x is greater than or equal to negative 3. So what kind of circle is going at negative 3?
I was golden.
A closed one, a filled in one, right? And which way have my arrow here? To the right. So are they gonna meet up? They're gonna meet up. So see how they meet up there? So we don't need any arrows because it ends up meeting up. Okay? And we're saying this we said will be the intersection. Well, this is where these two graphs intersect. This is the overlap here. Okay? Because this -3 one would keep going forever this way, the 3 one would keep going forever this way, but this is where they overlap here. This is where they intersect. So this is our answer. Now to write our answer in set notation, we'll put the x such that, raise x such that, and if we look up to this format again, it said smaller number, less than x, less than the larger number. So of these two numbers, which one would come first? Try again, which one's smaller?
The negative.
The -3. And if we go over here with the -3, we want to put less than, but we also need less than or
Greater.
equal to.
Oh, yeah.
Okay? We're going less than x, but in this case we need less than or equal to. We need to keep that sign the same, we're just flipping it around. Because if we're doing x, then we flip this inequality around, so we have to flip the sign as well. Right? We're flipping this inequality around, we have to flip the sign as well. And then, if I'm combining this in here, I already have the x, so I can put less than 3, the bigger number. And what we're saying here is the solution is anything that's bigger or equal to -3, but it's still less than 3. So is -3 part of the solution? Is -3 part of our solution? Is -3 greater than or equal to -3? Yeah, it's equal to it, okay? Is 3 part of our solution? Is that an open or closed? Open. So is 3 part of our solution?
No.
No, 3 is not less than 3, okay? So it has to be somewhere between those two numbers. Okay, we'll go and pack up with that, okay? We'll finish that section up on true reply to the next